All right, so in the last video, I showed you just the kind of general features of a quadratic function. So now we're going to actually kind of jump in and talk about how we can find that information, how we can find like the important stuff just by looking at the graph of a quadratic or the table. So for this one, we're just going to look at the graph. Even though there's a table here, we're going to kind of focus on the graph. And then on this one, we're going to focus on the table, and then we're going to just get all over these two. All right, so first of all, if I'm just looking, let's just, because I don't want to cheat, because you know, it's too easy. All right, so whenever I look at this, here's the important information. Here's the important stuff, okay? We have V, Y, X, X, AOS, RNG, and we'll talk about min-max here in a minute, okay? So I write this stuff down because this is the information that generally I'm going to want to know about, okay? And I'm going to be able to kind of figure that out by looking at the graph or looking at a table. So V is for vertex, Y is for y-intercept, X is for one or more x-intercepts. None of these examples have it, but let me show you. Okay, there's like, we could have, so you can see right here, I've got two x-intercepts, which are also called zeros of the function. I probably ought to start calling them z because y'all keep missing that on tests, but whatever. Okay, so I could have 2 zeros. I could have 1 0. So see either of these two ways. If it's sitting right on top of the x-axis, or if it's hanging off the x-axis, I could have only 1 0. Or I could have no zeros because my graph never even touches. I never even hit, I mean, it turns around before it gets to the x-axis, so I have no zeros or x-intercepts, okay? I want you to remember that the term zero and x-intercept, I don't want to say they're interchangeable, but they're interchangeable, okay? Zeros of the function are those x-intercepts. It's where does my line cross my x-axis. So we gotta stay on top of that. You gotta stay on top of that vocabulary. And I'm going to add more words that mean x-intercept. So let's get zeros on lock before I add 2 more of them. Okay. So vertex is easy to find. The vertex is that turning point. Okay. I see my vertex right there. And when we write these down, as I talked about in class, I want you to always write them down as ordered pairs. There's a very specific reason for this. Okay. You may see them written down on tests as like, if they write down, like, so when they write down the y-intercept is also 0, -7. And you may see the y-intercept written as -7. But if they write them as ordered pairs, they are always going to write 0, -7 and -7, 0. So they're going to flip the x and y because they're trying to trick you. So I want us to consistently and constantly be practicing writing those ordered pairs correctly so that they don't get us on that. We don't want to get tricked, okay? And we know that multiple choice questions are tricks, okay? So now when I look here at what's left here, I'm going to skip the x-intercepts real quick, and I'm going to go to the axis of symmetry because, as we talked about in the last video, I can find the axis of symmetry by finding x equals h. And remember, h is the x part, k is the y part. I'm not sure where h and k come from. I'm going to do some research and see if I can figure that out. M and B, I was able to come up with something. I don't know if it's true, but I came up with something, but I'm not sure about H and K, so I'm going to see what I can find out, okay? So, I can find my axis of symmetry by writing x equals whatever x is. So in this case, x equals 0. So there's the line, there's the equation for my axis of symmetry. Go me. My range is also easy. My range is y is greater than or equal to k, or y is less than or equal to k. And it's greater if my parabola points up, and it's less if my parabola points down. Well, my parabola is pointing up, so y is greater than or equal to k, which is -7. Okay? So we found a whole bunch of really useful information already. Now, this is where it's going to get a little tricky because these 2 zeros are not precise. They are not right on top of -3 and +3 like it kind of looks like they are. So we have to kind of constantly be thinking it's going to be between 2 values. Right here, is it going to be between 2 values? So right here I see it's between, I'm just going to write between -3 and negative 2. So I have a 0 between negative 3 and negative 2. And yes, that will be negative 3, 0 and negative 2, 0. But again, which one is it closer to? Well, when I look closely, it's closer to negative 3. We always want to be thinking about that because remember, they may not like, so maybe they say, what if they give me these two answer choices? Negative 2.8 and negative 2.2, and they ask me which one it is. Both of those are between negative 3 and negative 2, but which one's closer to negative 3? This one. So that's the one that I would pick. Okay? So we always need to be thinking, okay, even when I'm eyeballing it, which one does it look closer to? It looks closer to negative 3. Now, be careful about just writing down negative 3, 0, because they may also have that as an answer choice. If it's not exactly that, you want to really try to make sure that you try to be as precise as you can. Okay? But all that to say, I see another 0 right here between 2 and 3, and again, this one is closer to 3. Okay? All that information I just pulled off of this graph. All that information, all this good stuff. Okay? So let's try this one over here. Now this one we're going to look, instead of looking at the graph, we're going to look exclusively at the table. We're going to pull the same information out. Okay? So I'm going to write V, Y, X, X, AOS, RNG. And real quick, going back to this one, does it have a minimum or a maximum? It has a minimum because there is a lowest value I get to before I turn around and go the other way. Okay, so there's my minimum. Okay, now, for this one, again, I'm only looking at the table for this one. Okay, so the first thing I'm going to do when I have just a table of values like this is I'm just going to start matching up pairs, matching up symmetrical pairs, because when I match up those symmetrical points, I'm going to narrow myself down to the vertex, because the vertex is a point in the middle of all those symmetrical pairs that doesn't have its own matching partner. Okay, so I see a 2 and a 2, I see a negative 3 and a negative 3, a negative 6 and a positive 6. Oh, look, there's my guy right there in the middle. Okay, my vertex is negative 2, negative 7. And just because I know I'm going to write down the axis of symmetry in the range, I'm going to label that HK, just so I know. And right away, my axis of symmetry is X equals H, which is negative 2. This is pointing up, so my range is Y is greater than or equal to K, which is negative 7. Boom, I've already got that. I have a minimum. And my minimum is negative 7. Okay? All I did was find the vertex, and I got all that information. Okay? Now let's look for the y-intercept. So there's my vertex right there. Here is my y-intercept at 0, negative 3. Okay? And I got the same thing happening on this graph as I did on, well, on this graph, on this table as I did on the other one. But how can you tell when you look at a table what's happening? Actually, for that matter, how can I tell this thing is opening upwards from looking at the table? Okay? What you're going to do, and you know what? I screwed up. I'll admit that. When you're trying to look at just a table and figuring out whether you're opening up or down, what you do is you start from the vertex and you move out. Negative 7, negative 6, negative 3 to 9. Are those numbers getting bigger or smaller? They're getting bigger. And since they're getting bigger, that means my parabola is pointing up. And just to kind of jump ahead, be a little sneaky, right here, here is my vertex on this one. And when I go out from the vertex, I go 6, 2, negative 10, negative 30. I'm getting smaller. I'm getting more and more negative. And since it's getting more and more negative, that's how I know this one opens downward. Okay? So I've got my symmetrical pairs. So if they ask me for a point that was symmetrical to a point that was symmetrical to negative 5, 2, I would look for its buddy with the same y value. 1, 2 matches up. Now, what happens when something like this happens and they say, name a point symmetrical to 4, 29? Well, I don't know. How am I supposed to know that? I don't see it on here. What you can do is you can continue. Now, I know that 429 has a partner, so I can work my way back there. I know that 318 has a pair, and it has to have 18 for the y. If I continue, negative 3, negative 4, negative 5, negative 6, negative 7, I've got negative 7, 18. There, I continued my table. Okay? I can keep going again to find my point that's symmetrical to 429. I know it's got to have the same y value. and negative 5, negative 6, negative 7, negative 8. So these points are symmetrical, okay? So remember, we can use what we know about quadratics and the fact that they have symmetrical pairs. We can use that to help us backfill the table when we're missing something that we need to help us find one of those symmetrical points, okay? Now, I've got the same kind of problem here when I look at, I can tell that right here is one of my zeros, because here I went from positive 2 to negative 3, and to get from positive 2 to negative 3, I have to go through 0. So I know that right here is where it happened. Somewhere between these 2 points is one of my zeros. So I have one between negative 5 and negative 4. But which one is it closer to? The easiest way for me to figure that out is to actually just list it, okay? So I have 2, that's positive 2, I'm sorry about that. 1, 0, negative 1, negative 2, negative 3. Here's the halfway point. What's it closer to? It's closer, I'm sorry, we have to write this too, sorry, negative 5, negative 4. What's it, which x value is it closer to? It's closer to negative 5, so I can circle that. I can do the same thing down here with my other one. See, I passed from negative to positive, so I know that somewhere between 0 and 1, I have a 0. So I can do the same thing. I can make that same table. Okay, so I'm going from 0 to 1, and to get there I have to go from negative 3, negative 2, negative 1, 0, 1, 2. I have to get to 2. Well, that's closer to 1. So I'm going to circle the 1 to remind me when I'm looking at those values, when I'm looking at my answer choices, if it's multiple choice, to remind me that my value is going to be closer. Now we can estimate more precisely, but it's an estimate, because remember, these are curved lines. So if it was a straight line, I could figure out exactly where it crossed the x-axis. But it's a curved line, and because of that, it's not going to be, it's curving, so it's not going to be exact. All I can do is estimate at this point. We will be able to get precise answers later. Okay? Doing this with negative, with lines that point down, it's the same thing. There's nothing different except, obviously, instead of having a minimum, I'm going to have a maximum. Instead of my range being greater than or equal to negative 7, it's going to be less than or equal to negative 7. Okay? We will, in the next video, I will talk about figuring out, by looking at the equation, by looking at the graph, while looking at the table, whether or not something is whether or not it's a linear, a quadratic, or whether it's neither of those.